Based on the obtained results of post-hoc analysis, one question comes to our mind. Since if we move from category number 1 to category number 3, the salary increases steadily and significantly for each of the group. So is there a linear trend in data? Let me tell you at this point that ANOVA is a precursor to general linear modeling. So in fact it's a precursor to regression. So when you will do a regression analysis later, you will see that you are automatically given a one-way ANOVA. So in this case, we are having 3 groups, and when you move from one group to like say second group and third group, you see an increase in salary. A natural question comes to our mind, is there a linear trend in data? So you can do a trend analysis as well in ANOVA, and for that we are going to make use of one option called contrast. So we are going to check contrast and trend analysis for this data. So to do the contrast, click on contrast tab and you will see a polynomial here. So in polynomial you can test for various types of trend, like we have linear trend, quadratic trend, cubic trend, fourth and fifth root trend. So depending upon the kind of relationship you hypothesize between the independent and dependent variable, you can look for a trend. I'm hypothesizing a linear trend. So let me see if linear trend is significant. Press continue and OK. So once you test for linear trend, you see results here. And the results show that linear term is significant. So we are given more f values apart from the actual f value, and all the 3 weighted, unweighted and deviation based linear f values are significant. So it means there is a significant linear trend in data. So to check at the linear trend, we can have a look at the graph, and that we call means plot. One point to note while interpreting the linear term is that when you have unequal sample sizes, SPSS offers you 3 calculations for linear term, that is weighted, unweighted and deviation. And if you have equal sample size, then SPSS offers you just 2 calculations here, that is contrast and deviation. So in that case you should focus upon the contrast value if you are getting the linear term where you are having the equal number of people in different groups. So our case is the unequal number of people in different group, so we are going to focus on the linear term unweighted, and that gives us a message that there is a significant linear trend in data. So to check the linear trend graphically, we can do the means plot. To do the means plot, you can go to again one-way ANOVA, and in the options click on the means plot, continue and OK. So means plot is produced. So you can say this, like say linear trend appears to be there because when you move from clerical to custodial, there is an increase in salary, and again when you move from custodial to manager, there is an increase in salary. Now sometimes trends might be confusing. For example, this is a linear trend and we got a significant linear trend, and in the same data let's test for the quadratic trend that happens to be the curvilinear trend. So to test for quadratic trend, again go to one-way ANOVA and click on contrast and select the quadratic trend. Click continue. So now apart from linear trend, we also got test for quadratic trend, and sadly the quadratic trend again appears to be significant, though the value of quadratic trend is significantly smaller as compared to linear trend. So it means that we can see on the basis of ANOVA value, f value. So quadratic trend value is 53. For quadratic term and linear term value, the highest value is 865.59. So we can say linear trend is more pronounced as compared to quadratic trend, but at the conclusion level the trend is not clear. So as a conclusion we can say the groups are significantly different, though there appears to be a linear trend in data, but the chances of quadratic trend can also be not ruled out.